So in this question we have a circle. It has diameter 20 centimetres and AC as a diameter. And we have a point B which is on the circumference of the circle, and we know that the length AB is 12 centimetres. So here's B. We also have a point D which lies on the arc AC, so this arc here, on the opposite side to B, so over here. So there we have D. And we want to know what the sine of BDC is, and that's what we've labelled on as theta there. So to find the sine of this angle, we need to know some more things about the different lengths of the various sides. So we need to find BC. So why don't you have a go at trying to find BC now? Okay, so to do this we can use the fact that the angle in a semicircle is 90 degrees. And what this means is that if we have a diameter across here and two lines which join up to a point on the circumference of the circle, see the semicircle formed here, then the angle here is 90 degrees. And this is really important because then we can see that we have ABC, which is a right angled triangle. So why don't you use that to try and work out what BC is? Okay, so we're considering this triangle ABC, which I've just sketched there. And the theorem we're going to use is Pythagoras' theorem, which says that the squares of the lengths of the two shorter sides added together will give you the square of the length of the longer side. So we can substitute that in to find out what BC is. So BC squared is the longest side squared, which is 20, because it's just the diameter, minus 12 squared, which is this side here. And so we get that BC is 16. So let's just label that on. It's a good idea to just label things onto your diagram as you add them, so that you can see what information you have so far. So now we have all the information on here, and we want to find the sine of theta. So how do you think we're going to do this? Well, BDC, this triangle here, is also right angled for exactly the same reason. We have a semicircle here, and so this angle here will be a right angle. So we can use that to say that sine of theta of this angle here is just 16, the opposite side, over the hypotenuse, which is 20. And so sine theta is 0.8, and that's our answer. Notice that we couldn't immediately say what the sine of this angle is. We had to work out the side BC first. And we know to do this because we want to somehow bring in the basic trigonometry we know to find this, and therefore we need a right angled triangle. So we need to find a right angled triangle where we know two of the side lengths. So we had to find this side length and then use the fact that we have a right angled triangle.